Hi, welcome back to another video. So today we're going to solve the longest common subsequence question. This is a very famous interview question. So this question gives you two strings and you should find the longest common subsequence for those two strings. So how do we solve this question? So this is a variant of the longest common subsequence question. This one asks you to return the length of the longest common subsequence and not necessarily the longest common subsequence, but in other questions you're asked to return the actual common subsequence. So we're going to do a solution that would allow you to tackle both of those variants. Okay, so before we dive into the code, let's, illustration, let's talk about what a common subsequence is. So a subsequence is a sequence of characters in a string that are not necessarily adjacent, they're not necessarily next to each other as you would find in a substring, but they are ordered in the exact sequence they appear in the original string. So all substrings are subsequences, but not all subsequences are substrings. So say, for example, we have two strings, A, B, C, D, and C, A, B, D. A substring would be B, C, D. So this would be a substring. Just call it SQ. Now, substring, let's call it SS. Okay. A subsequence would be A, C, D. This is a subsequence, but it's not a substring at all, because A and B are separated, A and C are separated by the character B. So it's not a substring, but it's a subsequence. So I hope that was clear. You could Google what a subsequence is and you could get a lot more detailed explanation of it. There's like academic explanations that I wouldn't dive into, but that's the basic idea. So for this example, the longest common subsequence between these two strings is going to be A, B, D. It's A, B, and D. We also have another subsequence of AB, but it's shorter than ABD, so we should return ABD. So how do we solve this question? I think by now you should have guessed that we're going to use dynamic programming, as I kind of like dynamic programming nowadays. So we're going to compare two strings and then determine whether the characters at which we are at those two strings are the same. If they're the same, then we could mark that as a potential subsequence. If they're not the same, we could do a couple more computations. In particular, what we're going to do is we're going to remove one of the characters and then check what's the longest common subsequence we can get without that character. And we go to the next string and remove the current character that we're currently iterating at, and then check. We remove it and then check what's the longest common subsequence we could get out of that character. So we're going to simulate removing characters from string 1 and string 2 and iterating through the entire string. It's going to be a lot more clear as I go through an example, so bear with me. So here we have two strings, A, B, C, D, and C, A, B, D. However, every string in itself is made up of an empty string. It may not be visible, but every string has an empty string. What do I mean by that? Let's open up JavaScript console. Oh wow, that's a lot of errors. I never knew that parts of LeetCode was made with React, but you live and you learn. Okay, so let's declare a variable. Call it XYZ. I've already done this before. A new string. And then undefined. Pretty cool. But what if we print XYZ? See, we get an empty string, and then if we expand this, we could see that it has a length of 0, and then it has a primitive value of an empty string. So like we didn't specify that we wanted it to have an empty string, we just declared new string, but it came with an empty string. But let's say we wanna add something else to it. Let's say xyz equals xyz plus what? Hello. And then we get hello. So this is something that you may not really consider while solving this question, but this concept is going to help us come up with our base case for dynamic programming. Okay, so we have our two strings, A, B, C, D, and C, A, B, D. I reordered them because I felt like it would be a lot more intuitive to explain if C, A, B, D was a string we were comparing to A, B, C, D and not the other way around, but it could work anyway. Well, I feel like I should color this so it would be a lot more descriptive. So let's add the empty string. So for the empty string, I'm just going to put an underscore. So this represents an empty string, and I'll do that for the other guy right here, underscore. So we're going to iterate through both strings in kind of a double for loop, and then we compare characters. So when we're at character empty string, I don't know how to say it, we compare character empty string to empty string. Are they the same? Yes, they are. So we're going to have a variable called longest common subsequence that we update as we go. So I'm going to call it LCS. So when we're at empty string and empty string, are they equal to each other? Yes, they're equal to each other. So we append empty string to LCS. And then we get to empty string and B. They equal? No, they're not equal. So I'm just gonna like skip through that. It's like skip. And then we get to C and empty string. Are they equal? No, they're not equal. So I'm just gonna skip through that. You get the point, right? And then we get to C and A. So now what we're comparing in actual fact is empty string C and empty string A. So we get to C, compare C with A. Are they equal? No, they're not equal. So what we do in this case is that we either take out C and compare the rest of the characters, and we take out A and compare the other characters. What I mean by that is, we know that C and A are not equal, so we say to ourselves, well, what if we take out C from this first string? Let's say we take out C, and then cool, we've taken out C, and then we compare A to A. Are they equal? Yes, they're equal. It only turns out that the very first character that we took out appeared to have solved this instance, but sometimes we would have taken out this A right here and then compared C to B, and then we take out C and then compare C to A. But it only turns out that that's why I switched the characters, so the very first instance that we got to would be the perfect case. I just thought it would be easier to understand that way. Cool. A and A are equal, so we append A to the longest common subsequence. And then we continue. Need to bring C back, because we only took it out temporarily. Oh, that's too bad. And now we compare A to B. Are they equal? No, they're not equal, so this time, let's take out B. And then we compare A to C. That's this A right here to C. Are they equal? No, they're not equal. Then let's put B back to where it was. So we grab B, boom, put it back. So now let's take out A. Now we take out A, boom, and we compare B to B. Are they equal? Yes, they are equal. And then we append B to longest common subsequence. So now we have B. And then we put A back to where it was. And then we go to the rest of the example. Is A equal to C? No, it's not. A equal to D? No, it's not. So now we go to B. We compare B, the B in the first string, to the rest of the characters in the second string. So that's this B right here, compared to the other characters over here. And then we compare B to C, they're not equal, and then we go through that, yada yada yada, and then we get to D. Is D equal to this other D right here? Yes, they're equal, and then we append D to the longest common subsequence. Now, I realize that this would be a little fuzzy to understand, and I get it. I really get it. When I first saw this question, it took me a while to wrap my head around it, and it would be easier to understand if you visualize it as a two-dimensional array, and that's exactly how we're going to solve this question. So I'm going to build a 2D array, and then we're going to go through the example in a really quick pass. So this is our 2D array. We have the string ABCD on the rows, and then we have the string CABD on the column. And we've added underscore representing the empty string. So in these cells, what we're going to do is we're going to compute the longest common subsequence comparing strings in those cells, characters in those cells. So when we're in the first instance, in this first cell right here, we're comparing underscore and underscore. When we're here, we're comparing underscore and underscore A. When we're here, we're comparing underscore and underscore AB. I'm saying underscore, but I really mean empty string, so I hope you get the point. So that's it. That's the idea. So we compare empty string and empty string. What's the longest common subsequence? Well, we already know that it's empty string, so we put empty string. We compare empty string and empty string A. What's the longest common subsequence? We definitively know that that's empty string. So empty string ABC, empty string ABC, empty string ABCD, empty string. Cool. And now we move on to the next row. So for this example, I'm just going to go through the first column because all of it's going to be empty string. I hope you understand why I'm doing that, because that's going to be our base case. So we compare C and empty string. The longest common subsequence between those two is just empty string. Then we compare empty string CA to empty string. Longest common subsequence, just empty string. I'm just going to go through all the examples. So that's it. You get the idea. So how would this help us? Well, this would help us to continue building the other common subsequences for the other comparisons. So now we get to this cell right here. So we're comparing C, empty string C, and empty string A, and then we ask ourselves, is C equal to A? No, C is not equal to A. But what do we put in this cell? Well, we look above us and then we say, what's the longest common subsequence without C? The longest common subsequence without C is empty string. And then we look to the left of us. Here, we look to the left, that's this here, and we ask ourselves, what's the longest common subsequence without A? So when we're looking to the left, it's like we're alienating A from the comparison. And when we're looking to the top, it's like we're alienating C from the, removing C, alienating is a big jargon. We're removing C from the comparison. So then we compare those two and say, well, since C and A are not equal, then we could take the longest of those two subsequences without C or without A. What's the longest of those two? We don't have one, so we're just going to take empty string. And then we compare C and B. Are they equal? No, they are not equal. We look to the top of us and we look to the left. What's the longest common subsequence? It's just empty string. And then we get to an interesting case. We compare C and C. Are they equal? Yes, they're equal. So what we do, we just put C. And then we compare C and D. Are they equal? No, they're not equal. So what are we going to do in this case? We're going to look to the left. That's removing D. What's the longest common subsequence? It's C. Then removing C, what's the longest common subsequence? It's an empty string. So between empty string and C, which one's longer? C. So here we put C. And then we get to the next case. A, are they equal? Yes, we append A. And then we get to B. A, B. Are they equal? No, they are not equal. We look to the left. It's A. And then C, not equal. That's A. and that's A. And then we get to B. So here, is B equal to A? We're comparing here. B is not equal to A. But what's the longest common subsequence without B? The longest common subsequence without B is A. And what's the longest common subsequence without A is empty string. Compare A to empty string. Which one's longer? A is definitely longer, so A. I'm just quickly going to go through. Oh, snap, that's an interesting case. Okay, so now we get to this point. We get to B and B. Is B equal to B? Yes, B is equal to B. Now, instead of writing B, what we do is we check what's the longest common subsequence without the two B's? It's A. And then we append B to that subsequence. So it's like we say, what's the previous subsequence without B for the two strings? So it's like we have, let's say, A for the string 1, and then we have A, and then we have B here and B here. So for us to keep adding the subsequences, when we get to here, we're going to take all the subsequence from here, the longest common subsequence from here, and add it to whatever we get here. It so happens that this is a very cool example, so it's just going to be A, B. So for here, we're just going to append A, B. And then we get to B and C. What's the longest common subsequence? Well, B and C are not equal to each other, so we'll look to the left and we'll look to the top, and then we compare. Which one's longer? It's definitely AB. AB. Same for here, AB. Quickly just going to go through. Here's going to be A, AB, AB, and then when we're here, D is equal to D. So for this case, what we do is we take the longest common subsequence without D, and that is AB, and then we append D to it. So that is A, B, D. And then we return this as our final answer. So longest common subsequence is going to be A, B, and D. It's probably going to be more intuitive to understand as we go through the code. I always say that, but for me, I understand code better. So let's dive right into it. Oh, cool. So first thing we want to do is to declare a 2D array, and let's call it, how do you want to call it? Sequence. Let's call it sequence lengths. Since this question wants us to return the length of the longest common subsequence, so in the cells, we're going to store the lengths of the subsequence in that cell instead of the entire subsequence, instead of the entire string. So we're just going to store numbers instead of strings. New int, it's going to be number of rows. Let's say text 1 dot length, but remember we have to account for the empty string, so we add 1, and then we do the same. It should be text 2 dot length, accounting for the empty string, add 1. So we're done with initializing our sequence lengths. Now we have to populate it with the base cases. As we know, for empty strings, top row is going to be all empty strings. Top columns also going to be empty string. So we do that. Let's say fill top row. Don't know how to spell row. So for anti text 1 dot length. I think for top row, what we have to do is text 2 dot length. Sorry, sequence lengths. We already have sequence lengths. Sequence lengths 0 dot length. And then like this was. And then we just do sequence lengths of 0 and I is equal to 0, because the length of empty string is 0. And then we do that for the top column. Fill top col. And then sequence lengths. I and 0 is going to be equal to 0. So now that we have top row and top column filled out, what we have to do now is to fill in the middle cells. So we do a for loop. We use I for the row and j for the column. So now instead of starting from 0, all we're going to do is start from 1 instead, because we've already filled out the top row and top column, so there's no need to fill those out. I is equal to 1, I is less than text1 dot length plus 1 for the empty string, I plus plus, and then we do for and j is equal to 1. J is less than text2 dot length plus 1 for the empty string, and then j plus plus. So here we have to compare the characters at I and j of text1 and text2. So if text1 dot character I is equal to text2 dot character at j. So this would be the conventional way to do it, but if we do I, what we're comparing is, let's say if we have like A, B, C, and we start from 1, because we're starting from 1, I is equal to 1, we're comparing at index 1, and that is B. What we want is to compare at index 0, that's A, I minus 1, and then we do j minus 1 for the same thing for j. So if those characters are equal to each other, what we do is we look diagonally up in the 2D matrix for the longest common subsequence without those two characters. So going up, we are going to do a sequence length of I and j is going to be equal to whatever we have diagonally up. So that's sequence lengths of I minus 1, j minus 1, plus 1. Because we know I and j are equal. So else, if they're not equal, remember, we have to simulate removing either I or j, character at I or character at j, and see what's the longest common subsequence we had at that index. So sequence length of ij is going to be equal to, so this is going to be an if expression. So first we're going to compare above. So if sequence lengths, capital L, of I minus 1 and j, that's the one above, if it's greater than sequence lengths of, you guessed it, to the left, ij minus 1, then we return sequence lengths of I minus 1, j. Otherwise, we return sequence lengths of I, j minus 1. That's it. That's the algorithm. So I feel like I should do some comments. So if immediate top is greater than immediate left, take immediate top. Otherwise, we just take immediate left. Okay, so at the end of everything, what we have to do now is to return the very last column and row, the number at the very last column and row, because that's going to represent the longest common subsequence after we've gone through the entire 2D matrix. So return sequence lengths of text1 length and text2 dot length. That should be it. I'm quickly going to go through, make sure I have my semicolons, style guide, semicolons, and run this code. Sequence lengths has an S. Errors I should not be making. Cool, accepted. Submit this. And yep. I know this was a very long video, but I'm happy that I was able to dive deep into the way the algorithm works instead of you just looking at the code and looking at a fuzzy illustration and then memorizing how to solve it. So I hope this was informative. Let's dive into the time and space complexity of this algorithm. So for time complexity, I'm gonna erase this. We're going through two strings in a for loop, two for loops. So it's gonna be O of A times B, where A is the length of the first string and B is the length of the second string. So it's just going to be O of AB. That's for the one that we just solved. That doesn't require us to return the actual subsequence, but only the length of the subsequence. If you're asked to return the actual subsequence, the actual string, you might have to concatenate strings, and that would blow up the time complexity. But for the solution that we just did, since it just asked us to return the length, and we just stored integers and then added up integers, which was a bunch of O of 1 operations, that's fine. For space complexity, for the one we just solved, again, making sure to be really clear here, is O of AB, because we have a 2D array that only stores integers. If we stored strings, it would be different. So thank you so much for watching. I hope you learned something from this video. So like, comment, subscribe, and share it around the community. And I'll see you in the next video. Bye.